Hello everyone, this is Professor Audra Castonia going through some Week 3 tidbits. This chapter is all about solving linear equations. In this first portion of the video, we are going to review one-step and two-step equations. Now, if you had to take the foundations class, this was stressed throughout the entire course. If you didn't, you may recall some of these same procedures as we go along. So once again, just in this portion, we're going to go through one-step and two-step equations. One-step equation is just that. It's one step. Now, we also mentioned that these are linear equations. What makes an equation linear? Let's pose that question as I'm writing out our first problem. A linear equation, if you graph it, which we will be doing next week, is just that. The graph is a line. And when we say line in math land, we are referring to a straight line. Saying straight line is being redundant, just so you know. Now, how do we know that an equation represents a line? Well, we look at the exponent on our variables. The exponent on all the variables would be a 1. In this case, here's our x. There's no little power up there, so that is assumed that it's a 1. Because if there's no number up there, it's the 1. That's the God of my math land. He, she, it is always with us, is how I always word it. Okay, so we have x to the first minus 12 is equal to 15. Now this is an equation because we have an equal sign. Each side of the equal sign contains what we call an expression. Now if the expression was there all by itself, the rules that we would follow would be to simplify that expression or evaluate it. We do that by using our order of operations, parentheses, exponents, multiplication and division together, addition and subtraction together, left to right. But because we have an equal sign, we are now making this into a balance. The left side is equal to or the same as the right side. Now when we were first introduced to the equal sign when we were kids, we just thought that that meant the answer. 2 plus 3 is. There was that equal sign. Now we're realizing that it's not about an answer, it's about a relationship. The left side is equal or the same as the right side. And now we want to keep it balanced whenever we do any maneuvers here. And our goal is to try to get x by itself. This is like an unknown canister labeled x. And when we take away 12, it's the same thing as 15. So we want to find out what's in that unknown canister labeled x. So this is a one-step problem because on the left side with our variable, there's only one operation with it. It's asking you to subtract 12. Now when you are balancing an equation, we want to make sure that we cancel things out. We want to get rid of this minus 12. Well, the opposite of taking away 12 is to give 12. Giving 12 is the same thing as adding 12. Because a negative 12 and a positive 12, those are opposites, same number but opposite sign. When you add opposites, you always get 0. And we want to get 0 because what's x plus 0? When you add nothing, you're stuck with what you began with, and that's how we get x by itself. Now we can't just add 12 on this side because now our equation wouldn't be balanced. So whatever you do to one side, you have to do the exact same thing to the other side to keep your equation balanced. The x comes along because we didn't do anything with it. Once again, a minus 12 and a positive 12 cancel each other out, and you have equal on the other side, your simple addition to get 27. Your answer is still an equation, x equals 27. Because you started with an equation, your answer will be the same. That's for a couple of reasons. To keep it similar, and it identifies my unknown, x, in case we have other letters involved. So x equals 27. That's an example of solving just a one-step problem. Now, we've had other one-step problems. We've had something like 6x is equal to negative 42. Once again, you have to identify what operation you have. We have 6x. When you have a number and a letter mushed together, it means multiplication. To undo multiplication, we would have to divide. So when you have just a number letter next to your letter, divide to get it by itself. Whatever you do to one side, remember you do to the other side. In this case, 6 divided by 6 is not 0, because then you'd be left with 0 times x, and that would go away. Any number divided by itself is 1. So now you have 1 times x, and 1 times anything is anything, and that's how we get x by itself. On the other side, I have a negative 42 divided by 6. When multiplying or dividing, if we have opposite signs, that's a bad thing. In other words, the answer stays negative. And there's our solution. Those are 2 examples of solving one-step equations. Now it's going to get on a little bit larger, and we're going to do some two-step equations. How does the two-step equations change or differ from the one-step equations? Well, let's start off with one. Say 4x minus 7 is equal to 37. Now you can see that on the left side we have 2 operations. Let's move that down a little bit for you. We have 4 times x, so multiplication, and we have subtraction. So there's 2 operations here, and that's why we call this a two-step problem. Now, we can go through and solve this a couple different ways or realize it. I can explain it a couple different ways. One thing you might notice is, we have multiplication, subtraction. Order of operations says we do the multiplication first. That's true when you are simplifying expressions. As we stated before, though, this is not an expression because it has the equal sign. This is an equation, which means that we do different steps. We're actually undoing all of our order of operations and going backwards. So kind of like looking in a mirror and walking backwards to find those keys. So we're actually not going to do the multiplication first. We deal with the subtraction first. But we can't just subtract more. I need to cancel it because I'm moving it from one side of the equal sign to the other. So I have to do the same thing to both sides to cancel it out. So when solving, the first thing you're going to do is the addition or subtraction, then do the division to cancel the multiplication. That's always our order in a two-step problem. Another way of looking at that is we have 3 terms in this equation. Remember, terms are things that are separated by addition or subtraction, also equal signs. It's really important that you understand what is a term and what is a like term. Terms are a number, a variable, or a product, meaning multiplication, of a number and variables separated by addition. So in this case we have 3 terms. The first term is 4x because it's 4 times x. That's that product. Then it's minus. Well, we said separated by addition. Correct, but remember, subtracting is the same thing as adding a negative. So this is really adding a negative 7. So our second term is negative 7. The equal sign stops that term, and then on the other side we have one term, 37. So we have 4x is one term, negative 7 is the second term, 37 is the third term. 2 of those terms are what we call like terms. Like terms have the same variables raised to the same exponent. That's the 2-part criteria. Let me state that again. Like terms have the same variables raised to the same exponents. Now in this case, we only have one variable, it's in 4x. Well, technically the negative 7 and the 37 have a variable too. It's just raised to the 0 power. They are both like terms because they don't have variables. So we want to get the like terms together on the opposite side of the equal sign than the term that has the variable, the unlike term. So in this case, the first thing I'm going to do is add the 7. Get that term that's not like the 4x away from it. Once again, whatever I do to one side, I do the exact same thing to the other side. A negative 7 and a positive 7 makes 0, which is what we want. That's called the additive inverse, is the positive 7, and when we add and get 0, we get the additive identity. It's important to get the identity because it doesn't change what we started from. 4x plus 0 is still going to be 4x. Add over here, we end up with 44. Now we have the multiplication that we have to undo. We undo the multiplication the same way we did before by dividing by the number in front. Whatever you do to one side, you do to the other side. Multiplying and dividing by the same number, those are inverse operations. And the result is the multiplicative identity of 1. 1 times anything is anything. No, you don't need to know all those nasty words like multiplicative identity or additive identity. I'm just letting you know that there is a mathematical reasoning as to why we are doing the procedures we are doing. And get your answer of x equals 11. Now, you don't have to take my word for it that that's the correct answer. You can check all of your answers, and that's the important feature on solving equations, is to remember that you can always check. If you go back into your original, we had this 4x minus 7 was equal to 37. We now know that x is 11. It means the same thing as 11. So in this equation, I can replace the x with 11 because they are equal or mean the same thing. So I'm going to go through here and replace my x with the value I came up with. So I now have 4. Now I have to indicate multiplication, so I'm going to put parentheses in to indicate multiplication. If I don't, if I just leave it not without a symbol there, it's going to look like the number 411. So be very careful there. You can use the multiplication dot as well, but oftentimes with all the numbers, the multiplication dot gets lost. So I don't want to do that. So I'm just going to use parentheses. Now I'm simplifying this side of the equal sign. Because I'm simplifying, that's when we use the order of operations. So to simplify that, I would do my multiplication first and then the subtraction. Multiplying, we get 44 minus 7 is equal to 37. Then we take 7 from the 44 and we end up with 37. The left side equals the right side, it checks. Now this is not my solution down here. The solution is still up here. X is equal to 11 is my solution. This was just the check. Now I know for sure that I got it right. And that is how we solve one-step and two-step equations. However, linear equations can have a few extra steps to it. In the next segment, we'll go through some of those other techniques. Before we begin this section of adding some more steps and different things to our linear equations, I'm going to review one more two-step equation. Now, it's really important that you learn the proper steps in solving an equation. You may be able to look at a lot of the first or the one-step and two-step equations and come up with an answer without solving it. The problem is, in math land, the numbers and the equations are not always going to be that easy. It's really important to be able to have the skills, the proper steps and procedures to solving it for when you don't have questions that are so easy to look at and know the answer to. That's why we learn the procedure. So make sure that you take the time to learn the proper steps so that you can use those same skills when we get to bigger and uglier equations. Okay. Once again, here we have a two-step equation. We know it's a two-step equation because we have this negative 5x. Remember, that's a negative in front, not a subtraction sign. There's nothing between the number and the letter, so we know that that's multiplication. Negative 5x plus 6 is equal to 16. So we have the multiplication and addition on one side of the equal sign and just a single value on the right side of the equal sign. Once again, our goal is to get the variable by itself. Now the first thing we do is we get the term that has the variable by itself. That's the negative 5x. It's okay that there's a number right next to the x at this point. We want to get all the other stuff away from it. Then we'll worry about dividing and conquering. So in this problem, we are adding 6. To cancel out adding 6, we have to take away or subtract 6. Once again, whatever I do to one side of the equal sign, I have to do the same thing to the other side to keep it balanced. We now have just our negative 5x on that side. 6 minus 6 is 0. And on the right side, 16 minus 6 gives us 10. Now we have this multiplication that we have to undo. So in order to do that, we once again divide. Now whenever you multiply or divide, you keep the sign of the number in front, because we want to find out a positive x. And two of the same sign when multiplying or dividing is a good thing, meaning it gives you a positive answer. So again, whatever you do to one side, you do the other side. Any number, -5, divided by itself, -5, is a positive 1. That's another way of looking at that, to give us a 1 times x, but 1 times x is simply x. No, there's no minus sign in here. I'm just canceling these out and leaving a 1 behind. We have the tendency to think that when we cancel, we get 0, but that's not true. There's always a remnant left over. On the right side, I have a positive divided by a negative. When we're multiplying and dividing and we have mismatch signs, that's a bad thing, so the answer is going to be negative. Now be very careful. On a problem like this, we have the tendency to go a little bit too quickly. Talk it out loud and say the operation. It's 10 divided by -5, not 10 minus 5. So the answer here is not 5, but a -2. Make sure that you review those things and work it through slowly. As always, I would strongly suggest that you go through and you put your answer back into your original problem. You don't necessarily need to show that on your homework, but it's a good practice to always do. Check your answers. Make sure that you're doing it right. Now, let's change things up a little bit. Let's add another step in here. What if we had 2m minus 3 minus 8m is equal to -27. Now we need to identify what's different on this problem than our other problems so that we know what we might have to do to simplify it. Now what I notice on this problem is I have two variables, or two terms, with the variable m in it. Now I have a total of 1, 2, 3, 4 terms in this problem. But two of the terms are like terms on the same side of the equal sign. If they're on the same side of the equal sign, we do not switch anything with their signs. We simply combine like terms like we would if this was an expression. So in this case, it's 2m minus 8m. 2m take away 8m would leave me with -6m. Once again, those terms are on the same side. This is a negative because the sign in front of the term goes with the term. So we'd have -6m. Now I didn't do anything with the -3, so that comes along for the ride. Still have our equal sign, and now we have the -27 on the right side. Now our problem looks just like the previous one. We have a two-step problem. The first step is to get all of my like terms together on opposite sides from their unlike terms. So the term with the m, since these don't have m's, is the unlike term. We want to get that away and keep the ones that don't have the variable together on the other side of the equal sign. So in this problem, I need to cancel out the subtracting 3. We always switch signs when we move terms. Terms are the stuff that's added or subtracted. So I have to move it over by adding 3. That leaves us with a -6m on this side is equal to, now on the right side I have a negative number and a positive number. When we have one of each sign, we subtract the two numbers and keep the sign of the number that's further from 0. In this case, 27 is a whole lot further from 0 than 3. So the sign on the 27 is negative, so the sign on my answer here is negative. Now we continue on, and we get m by itself by canceling out the multiplication. Once again, this is not subtraction because the horizontal bar is not between the number and the letter. It's out front. So this is saying -6 times m. To undo multiplication, we divide. The sign goes with when you multiply or divide. So we get m is equal to, once again here, multiplying and dividing, same signs is a good thing, so that ends up being positive. always check your answers. Go back into the original equation, replace all of your m's with 4, and simplify. The left side should equal the right side when you use your order of operations. So if we have terms on the same side of the equal sign, you'd have to combine them first before solving your equation. Let's look at one that's fairly similar and see if there's a difference to it or not. Let's try a problem like 2x minus 7 is equal to 3x plus 4. Now in this problem, we also have two terms with the variable and two terms without the variable. But here we should notice that the difference is that the terms with the variables are also on opposite sides of the equal sign. On our previous problem, they were on the same side of the equal sign. Here, they're on opposite sides. So in order to gather them, we have to move across the bridge, or that equal sign. Whenever we move across the bridge, that's when we switch our order of operations. That's when we do the opposite to add it to the other side or subtract it. We're not going to do same signs. Now there's two steps that we could have done for this one. We can move the variable term always to the left. I know a lot of students like to do that. Just always have the variable on the left side and the numbers on the right side and go from there. That's fine, but in order to do that in this problem, we would have to take away, since we're moving the whole term, that's when adding or subtracting happens, it's a positive 3x because the sign in front of the term goes with the term. If there's no sign there, it's assumed positive. So to move this whole term to the other side, we'd subtract 3x. Now if we subtract 3x on this side though, we'd end up with 2x minus 3x, which would leave us with a negative. I, in my math land, prefer to work smarter than harder. Negatives always mess with us, so why put ourselves in that predicament to have more negatives? Let's stop and look at the problem first of all, and maybe we can avoid some of those. So what I always do is I take the term with the smaller number in front and bring that term to the larger number. So instead of having my variables on the left side, I'm actually going to move them so that they're on the right side. Once again, this is a positive 2x because there's no sign in front, so I have to take away 2x, and whatever I do to one side of the equal sign, I do to the other side. We're moving the entire term. Whenever you move terms, we add or subtract. Notice the x is going with the number. That's the entire term, which is why we're not doing any division. The sign in front of the term goes with the term, so do not lose this negative by the 7. Remember, subtraction is adding a negative, so that 7 is really a negative 7. These are my like terms. They are like terms because they have the same variable to the same power. We can only add or subtract like terms. And when we add or subtract like terms, we add or subtract the big numbers in front, called coefficients, and leave the variables the same. If we're adding and subtracting because they're like, they're going to stay the same. So 3x minus 2x is 1x. Now when we have 1x, we usually don't write the 1, because 1 times anything is anything. Whew, that was a lot in there, wasn't it? Might want to rewind and listen to that one again. Okay, but 3x minus 2x is 1x. We don't usually put it in there. If you want to put it in there, that's fine. Here we bring down the plus 4 because that comes along for the ride. Now I have to get the term with my variable by itself and move the unlike term. Because I'm moving terms, we add or subtract. We do the opposite of what's happening to it. This is a positive 4, so I'm going to subtract 4. I'm moving the 4 because I want to get the x by itself. In order to do that, I just have to get rid of the number that's being added to it. So we subtract 4 there, subtract 4 there. This is a negative 7 and a negative 4. When we have same signs, that's when you add the numbers and keep the signs. Now, you can write it like that. Negative 11 is the same thing as x. But if you do like to have your variable first, you can. Just be careful in writing it. X is equal to negative 11. Not a big deal in this case, but it would be if this was an inequality. The sign of your inequality, those are those greater than or less than symbols, less than or greater than symbol, we'd have to make sure that the open side is still towards the variable, if that's the way the problem was written. When you write it the other way. Okay? So in this segment, we had two terms with a variable term. Our first example, they were on the same side of the equal sign, so we just combined them as they were. In the second example, they were on opposite sides of the equal sign, so to move the terms, we had to do the opposite sign to get them together. And then we solved from there. Now, what's going to happen if we have some parentheses in? That is our next step in the next segment of week 3 videos. Here we're going to do the last step, or the more difficult looking linear equations. In this particular example, it's a little bit scarier because of the parentheses. Now, we'd want to do any cleaning up of an equation that we could first, and that goes back to our order of operations. But inside the parentheses, we cannot do x plus 4 because we don't know what x is. X is an unknown, so we can't add 4 to it, because if x was a 1, we get 1 plus 4, we'd have 5, but if x was 72, 72 plus 4 is 76, we get 2 different answers. So we cannot just add that, and don't start turning it into multiplication. Remember, 4x means 4 times x. Adding 4 is not the same thing as multiplying by 4, so be careful there. But we still want to get rid of those parentheses. And the step that we do in order to get rid of those is called the distributive property, because the second reason that these parentheses are there is to indicate multiplication. That's what the 3 is doing in front. The 3 is being multiplied to this quantity. That means that the 3 is being multiplied to every term inside the parentheses. So take your 3 and distribute it inside first by taking 3 times the x and 3 times the positive 4 for the 2 terms. Now the 2x out in front has nothing to do with that, so we just bring that along for the ride. But now we have plus 3 times x would be a positive 3x. And 3 times 4, well, we still need to separate the terms, so we need the plus sign to separate terms. And that's going to be equal to the negative 3. Now, after we get rid of the parentheses, we may notice that we have some like terms. If we have like terms on the same side of the equal sign, we just add them the way they are. If we have like terms on opposite sides of the equal sign, to get them together, we have to do the opposite or the inverse operation. The inverse of addition is subtraction. The inverse of subtraction is addition. Similarly with multiplication and division, they are inverses of each other. Now in this particular problem, we just have some like terms that are being gathered. On the left side, we have a 2x plus a 3x, so that would give us 5x. We're not moving it across an equal sign, so the sign does not change. So we have 5x plus 12 is equal to negative 3. And now, just like that, we're in our two-step problem that we did in the beginning. We have 3 terms. 2 of them are like. We want to get them on the same side of the equal sign, away from the term that's not like it. It's a positive 12, so we need to subtract 12. What you do to one side, you do the same thing to the other side. The 5x comes down for the ride. Those cancel out. Make sure that it does. Sometimes we miss our signs and we do the same sign. Double check. 12 minus 12. Yep, that's 0. On this side, it's a negative 3 and a negative 12. Same sign, so add the numbers and keep the sign. Add the numbers and keep the sign. Now we need to get the x by itself by getting rid of the multiplication. They're not like. Numbers and letters aren't like after all, so we want to divide and conquer. So to cancel this multiplication, divide it by 5. If I do that on one side, I have to do the exact same thing on the other side to keep it balanced. And we get x is equal to -3. Once again, you can always check all of your answers by plugging it back into the original for all of your x's. Simplify using the correct order of operations. Please excuse my dear Aunt Sally, also known as PEMDAS. But our solution has the variable attached. It's x equals -3. That one wasn't so bad. Let's do another. Ooh, I have a good one here. I think we'll like this one. 2 minus 5 times the quantity of x plus 5 will equal 3 times the quantity of x minus 2 minus 1. Now, lots of steps to talk about in this one. First of all, I see parentheses, and we don't want any of those. But before I even go into that, I want to make note of what happens out in front. 2 minus 5. A lot of us would think, hey, I can do that and come up with a -3. That's a big boo-boo. Because remember, what's happening to the 5? There's parentheses after it, which indicates multiplication. According to our order of operations, we have to do multiplication before we do subtraction. If you didn't do the multiplication, you can't do the subtraction. So we cannot take the 2 minus 5. The second thing to look at on this problem is the sign in front of the 5. That same 5 we were talking about. We're subtracting. We need to remember that all subtraction is the same thing as adding a negative. So when we do our distributing here, we're not distributing through a 5, we're distributing through a -5. All subtraction is the same thing as adding negative numbers. So if there's a subtraction sign in front of a number, it really means that that number is negative, and the negative has to go with, because the sign in front of the term goes with the term. With that being said, I can now use my distributive law to get rid of my parentheses. Take the -5 that's on the outside and distribute it or multiply it to every term inside the parentheses. We're going to do the same thing on the other side over here. It's 3 times the x and 3 times the -2. Notice I'm not taking the 3 times the -1. That's outside the parentheses. It's not what the part that's being multiplied. So when we do that, the 2 out front comes along for the ride. Nothing that we're doing there. -5 times x is a -5x. We write that as minus 5x. It's either a negative or it's a subtraction, not both. -5 times a positive 5 is a -25 equals 3 times x is 3x. 3 times a -2 is a -6. There's still a different term, so you need to have a sign to cancel out or to separate my terms, to separate your terms. And then don't forget that -1 at the end. Your next step is to clean up your like terms on either side of the equal sign. On the left side, we have like terms. What are they? Yes, the like terms are the 2 and the negative, the -25. So I'm taking 2 and I'm subtracting 25 from it. -5x, we like to keep the terms of the variables by itself. 2 minus 25 is -23. Excuse me, I should clarify that. We like to keep the term with the variable first. Doesn't have to be, but we like to do that. Is equal to, and on the right side I have like terms as well. The 3x is not part of it. It's a -6 and a -1. Remember, the sign in front goes with. So a -6 plus a -1, if you change everything to adding negatives, it might be easier to see. I have a -6 and I'm adding a -1. Two of the same sign, we add the numbers and keep the sign. So that's going to make a -7. Now we have a problem in which we have terms with the variables on both sides of the equal sign, and we have constants numbers that don't have the variables on either side of the equal sign. I think your book and several others like to move the terms without the variables first. I don't like that so much. And the reason why I don't care for that is because then you can't make sure that the sign in your variable term is positive. As we stated before, I always like to make sure that the number in front of my x stays positive if I can at all control that. So I'm going to move those first so I can control it. Once again, in this case, I'm not going to be moving the 3x to the left side because negative 5 is further from 0 or a smaller number than a positive 3. We always want to move the smaller term to the larger term because when we switch the signs, it becomes a larger number. So to cancel out negative 5x, I'm going to add 5x. Negative and a positive get 0. Whenever we move terms, the entire quantities that are being added or subtracted, we do the opposite sign. Whatever I do to one side, I do the same thing to the other side. Don't forget the sign in front of the term goes with the term, so this 23 is still a negative 23. And now I have an 8x minus 7. My next step is to get the constants, or the terms that do not have variables, next to each other. I want to get them on the opposite side of the term that has the variable. So once again, I want to move the constant from the right to the left. It's a negative 7, so I want the opposite of that, which is a positive 7. Whatever I do to one side, I do the same thing to the other side. Now on the left side I have a negative 23 and a positive 7. One of each sign, we subtract the numbers and keep the sign of the larger, or the number that's further from 0. 23 is the larger number in the fact that it's further from 0. And it's negative, so my answer will be negative. Then 23 minus 7 is going to give us 16. And finally, to get our variable by itself, we need to cancel out this multiplication. To do that, we once again divide by that number in front. X is equal to a negative divided by a positive. One of each sign is a bad thing, so the answer is negative. So let's summarize the steps that we're going to do whenever we are solving linear equations. The first step that we want to do is to remove parentheses. Let's make sure our paper's on here, huh? To solve linear equations, the first thing we always do is remove parentheses. And we do that by using the distributive property. That's what we did when we multiplied inside. The second step we do is to collect or combine like terms. After we use the distributive property, we might have like terms like we did in that last example that we have to combine. We want to simplify things next, so that's our second step, is to combine or collect, your book calls it, I think, like terms on both sides of your equal sign. It's really important that you understand what terms and what like terms are. So combine or collect like terms on either side of the equal sign. Remember that this will be adding or subtracting, whatever the sign says. If we're not moving from one side of the equal sign to the other side, we keep the sign of the term. For example, in that last problem, we were adding our like terms here. It was 2 minus 25. We didn't switch the signs and add because we're on the same side of the equal sign. So we simply took 2 minus 25 to get our negative 23. Similarly, on the other side, the negative 6 and the negative 1, we kept the signs and simplified them as they were. So that's the second step. Your third step is to move all variable terms to one side of the equal sign. Move the variable terms. Those are the terms with the variables. And we do that by using inverse operations. Once again, the inverse of addition is subtraction. The inverse of subtraction is addition. Whenever you move a term, you're adding or subtracting. Step 4, when solving linear equations, would then be to move your constant terms to the other side. Those are the terms that don't have the letter. And once again, that's inverse operations. We always did that in that purple color. And once again, since we're moving a term, we're adding or subtracting. And then your last step is to get the variable by itself. That last step would have maybe a number in front of the variable. And remember, that means multiplication. So the last step is going to be to divide both sides by the coefficient of the variable. Coefficient is a big word. It simply means the number in front of the variable. And yes, for the purposes that we're doing, we're going to be dividing. Technically, you could be multiplying if there is division there, but we're not really going to be doing a whole lot of those types of problems. Right? So those are the 5 steps for solving linear equations. Remove the parentheses using the distributive property. Combine or collect your like terms on either side. This is when we keep the signs the same as what's there, and we're just gathering them together and simplifying. Move your variable term to one side of the equal sign. We'll add or subtract to do that. Move the constant term to the other side of the equal sign by adding or subtracting as well. And then divide both sides by the coefficient, or that number in front of the variable. Those are your steps to solving a linear equation. Remember, you can always check your answer to know if you got it right for sure. This chapter also covers percent problems. Now, I remember being a kid and having those problems. What percent of this is that? Blank is blank percent of what number? Blank percent of blank is what number? Etc., etc., etc. Those types of problems. And I remember clearly getting every single one of them wrong. Yep. When I was supposed to multiply, I divided. When I was supposed to divide, I multiplied. When I was supposed to divide, maybe I would divide the wrong direction. I got them wrong all the time. And then I had a teacher that taught me the box. Now this particular chapter is not focused a lot on percent problems. However, in your future workplace, there's a good chance that you're going to have to deal with percent problems. And so I want to go over this shortcut that I learned using what I just simply call the box. Okay? And this is what happened. My teacher simply said, organize a little box. I think it kind of looks like a window because you put the little panes in, or a present, or here are my curtains hanging in my window, makes me happy. Okay, anyway, in the lower left hand box, you will always put the number 100. Above that is always the percent. And then if you really were careful in reading the problems, there was always this is and this of type of number. Well, the is number goes on top and the of number goes underneath it. It's alphabetical. Okay. That's the simple little setup of the box. Okay. That's where everything goes. Here are some neat things about the box. The percent, because it's over this 100, you do not need to convert the percent into the decimal. Now, if you really know anything about percents, if I tell you 25%, the number that's collected from the data is not the number 25. It's the number 0.25. But we don't understand decimals that much. So if I say, oh, 0.25 people agreed with blah, blah, blah in this poll, we would be confused. So what we do is we make these numbers out of 100. That's what percent means. Per means divide, cent means 100. So instead of saying 0.25 people, we would say 25%, which means 25 out of every 100 people agreed with blah, blah, blah in the poll. So percents aren't actual numbers, they're representing decimals that we're too scared of to deal with. And so we make it out of 100. It also helps when we're polling different numbers of people. Maybe one study is asked 1,000 people, maybe another study asked 50,000 people. Well, you can't go by the number of agrees with that question in the poll because your sample sizes are too different. Anyway, this is how the box works. You know that the questions are always as I stated up here. It's always this, blah, blah, what percent of this is that, blah, blah, blah. That's where the percent is and of come from. So if I give you the example that says, what percent of 180 is 36? Okay. In order to simplify the box, I have to translate my sentence. This is the order that I translate the sentence. The first thing I always look for is the percent symbol, or the word percent. It's the easiest to identify. So in this problem, there is no percent symbol by either my numbers, so my numbers are not percents. Here's the word percent, and what's right in front of that? Oh, the word what, meaning I don't know. So that's what I'm solving for in this problem. It's asking for a percent. So I don't know the number that's above the 100 in my percent box. So that's when we replace it with our favorite letter, X. Then the second thing I look for is the word of. Of is what we call a preposition. It leads off a prepositional phrase, part of the sentence that just gives us more oomph to it. A prepositional phrase has a noun. Numbers are nouns. So right after the word of would be the number to represent the of. Why do I do that second? Well, look at this problem. I have a 36 after the is, and I have a 180 before the is. I have numbers all around here. How do I know which one is going to be used? That's why I don't go to is next. I go to of. Here's my preposition. Right after that is the phrase, and it stops before the verb is. So here's my of, here's the of number. So in my of box down here, I put the number 180. Finally, I look for the is. And any number that's either before or after the is going to be my is number that hasn't been used yet. Here's my is, here's the only number I haven't used yet, so that goes in my is box. That's how you set up the box. Now, how do you solve the box? Gets even easier yet. The box has 4 spots. 3 of those spots have numbers in it. 1 does not. Since there's 4 spots here, we have 2 diagonals. Here is a diagonal, here's the other diagonal. You locate the diagonal that has 2 numbers. Here it is. Those 2 numbers you multiply together. And then you divide by the 3rd number. And that is equal to your x. For those of you who are familiar with proportions, you're just setting up a proportion. Those of you who like those types of problems, this is cross multiply and divide. Now you can simplify this a couple different ways. You can get out your handy dandy, or I notice that, gee, I have a number up here that ends in a 0 and a number down here that ends in a 0, so I can cancel those out. Ooh, 18 goes into 36, 18 goes into 18 once, 18 goes into 36 2 times. I'm left with 10 times 2, so x is equal to 20. Now x represented a percent. You need to put the percent symbol, because remember, that's not really the number 20, it's 0.20. So your answer of what percent of 180 is 36? It's 20%. Ooh, that was kind of fun, wasn't it? Let's see what else we have that's similar. How about 45 is 30% of what number? Once again, it's already set up in that nice little fashion, so I'm going to make my little box. No, you probably won't be able to make the cute little box in the equation editor, but you can set up a proportion or a fraction, and I'll show you that in just a minute after we have this one set up. Once again, the first thing I'm going to look for is the percent. Here it is. There's a cute little percent symbol and a number by it. So I fill that in. Always above the 100, the number just as I see it. The second thing I look for is my preposition of. Here it is. It always has a noun afterwards, so that's what I'm looking for. Oh, all the way until it ends. Of what number? Once again, there's that question word meaning I don't know. So my of is what I'm solving for this time. That one has my variable in it. And last but not least, I look for the is. Here's is. There's a number right before it. It's the only number I haven't used yet, so that goes in my is box. And then to solve, we find the diagonal that has 2 numbers. We multiply them. And then divide by your 3rd number. Well, let's see. Once again, I think we can do some reducing here. Ends in a 0, ends in a 0. 3 goes into 3 once. 3 goes into 45 15 times. We're left with 10 times 15, so x is equal to 150. It's not a percent because we're solving for the of. So if it was $45 is 30% of what number? It'd be of $150. Now, those are the basic types of percent problems. What's going to happen, though, is occasionally they're going to ask for something like a percent of increase or a percent of decrease problem. Now, this is a little bit more in depth and a little bit more difficult, but still not overly. We just have to think about the numbers. If they ask for a percent of increase, and like I said, perhaps they won't in this course, but in your future jobs, there's a good chance that you're going to have to take some sort of employee intelligence test. They love to put percent problems, and they love to put work principle problems on those types of tests. So that's why I'm going through it. Percent of increase. An example of a percent of increase problem would be, say we have a population question. Say the population of Green Bay in the 90s, I remember the sign used to always say this at least, I do believe it was 97,477. And then let's say the population in Green Bay today, according to the signs that I pass all the time, is 102,313. You can tell that our population increased from the 90s to what it is today, or at least the last time that they updated that census sign. Now, if I want to find the percent of increase, the key thing that I need to remember in this problem is that I don't know how many people it increased by. So I can't find the percent that's attached to how much it increased by until I find out the amount of increase. How many more people are there living in Green Bay today than there were in the 90s? In order to find that, we have to subtract. So the first thing we're going to do is we're going to take today's population and we're going to subtract the old population to find out how many people it increased by. And if my math is correct, and feel free to check it out, see if I did that correctly quickly, is 4,836 people. So now what happens is we want to change that into a percent. We can actually go back to the box at this time. Okay? Box at this time, we need to realize, let's see, I'm at the edge of one piece of paper. We're still having the 100 down here. We're trying to find the percent, so that's our unknown up here. Now, what's the is and what's the of? The of amount is always your original amount. This is before an increase or a decrease. So even though you think that you're going to use today's population of the 102,000, you're not. You're going to use the 97,000 because we're increasing from there. Okay, so in this problem, this is going to be the 97,477. In the is box is the amount that the increase or the decrease is. That's what we came up with here. How many people moved in, that goes in here. The amount of the in, or if we have a decrease, goes there. In this case, it's an increase. So the 4836 goes in that box. And now that we have the box set up, we can do the same math that we've done before. Find the diagonal with two numbers and multiply them. And then divide by your third number. This gives you the percent. This translates the number of people that added on and turns it into the percent of increase. You can do that math to find your percent of increase. Once again, that works for percent of increase or percent of decrease problems. You have to subtract first to find out the amount that was actually increased or decreased. And then in your of box, you always have the original amount before there was an increase or a decrease. What number did you start with? That goes in your of box. Hope this helps.